So good afternoon, everybody. Welcome to the webinar from the Solar Labs. It's great that all of you have been able to join us on this afternoon. I really hope everybody is safe and they're maintaining social distancing. And we hope everybody in your family is safe and sound as well, and you're in your company. So we have here, gathered here today so that the solar design software from the Solar Labs will be showcased. And we here bring you an opportunity to learn more about a new software in the industry where there's a new way to do the same things and a better way to do the same things. So from rooftop solar plants design and engineering to creating sales proposals, we will see how in the next 1 hour, we'll be looking at the company, the Solar Labs, what we have to offer to you, what we are proposing that solar companies all around the world, and how they're how they can improve their operations and design process, while also in this tough time be able to maintain their team's productivity as well. So this 1 hour, almost 45 minutes to 1 hour, will be divided into say 10-15 minutes of the company, the Solar Labs, how what you can do using the Solar Labs, and then we'll spend the next 30 minutes along with question and answers to do the designs using the software. So I'll start by talking about our company. We'll be seeing what we offer through the Solar Labs. We'll showcase some designs that have been created using the Solar Labs. We'll see how for remote sales and operations. And there's something very exciting that I'm very looking forward to share with you guys is a large-scale analysis project. And if you stay till the end of the webinar, we'll show you how you can integrate, we'll give you a whiff of how you can integrate drones into your remote workflow. And we'll show you how we have done one project regarding where we didn't even need to visit a site, and we did a 500-acre site survey and took the data of 100 buildings and presented to our client with a 3.5 megawatt solar potential analysis. So if you stay till the end, we'll show you how we did that as well. So TSL, the Solar Labs, also TSL was founded by IIT alumni to accelerate solar adoption in the world. The intention to accelerate solar adoption comes from the problem-solving capabilities that startups have, where using software and technology, we want to address climate change problems at the root, where if we are able to, improve the workflows and design criteria of solar plants, we will have played some important efforts to help accelerate the solar adoption. So we intend to help you create, using a software, we want to help you create optimized solar systems and reduce the cost of installations. And at the same time, you can use a software to create sales proposals in just 20 minutes. So far, our software has been used to estimate more than 100 megawatt of solar capacity across India. So from 3 to 4 kilowatt rooftop solar plants to 2 megawatt solar plants have been created using our software. So let's just take a step back and try to see what is the solar industry looking like for the world since the past decade. So we've seen that the solar industry is one of those markets right now where there was a massive investment in the last decade. We saw an investment of $1.3 trillion. It's an economic engine of growth where you have got investment opportunities and job creation factors playing here. We have seen in India the installed capacity go from just 161 megawatt to 37.6 gigawatt. And this 37.6 gigawatt has 4 gigawatt of rooftop solar in it, where in 2020 March, we saw 4 gigawatt being touched. And we hope that through our partners, through the solar EPC companies in India and better business models, the Solar Labs want to support the journey of reaching 40 gigawatt of rooftop solar in the next 2 years. So how do we suppose we are going to help you do that is we have an offering where using our software and the sales cycle which is enabled through our software, you should be able to grow your sales. Then it is a software where it's meant for solar design, right? So it's not like any other company where you use a different software for solar design, but this is a software built for creating optimized high performance photovoltaic layouts. And at the same time, we want to help you reduce your costs so that everybody in your team is using a single software and collaborates better with more productivity and using some time-saving automations. We have some case studies. If you're interested, you can reach out to me where using a software, people who used to use SketchUp and AutoCAD compared to our software, we can provide time savings of up to 80%. What is more better in what we provide is that we have live support capabilities so that anytime you're stuck in designing any kind of a rooftop, we will be there to help you create those designs. And like I said, we enable remote work, and we're working on the functionality where we can, integrate drone data or 3D data of cities and industries inside the software so that you can reduce your site visits. And the last thing that we are offering is an enterprise solution, which we will look into as we proceed further. So like I was saying, our software is used from multiple designs, right? From residential designs to industrial designs. But how do we enable that, and how do the designs look like? So I'll show you some of the projects that have been created using a software. So these are some of the designs that have, very amazing designs with accurate data from the sites. We have created a dome-shaped roof, multiple table layouts on the same project. We have another design here with a 240 kilowatt system on the roof. And what's quite unique is that this roof was not able to accommodate so much solar, but through a design software that helped them visualize how to place the panels is when this project was made possible. Similarly, we have, the software is capable of creating any kind of shed roofs with also the capability of yourself uploading your AutoCAD files and drone imagery as the base map layer. So it's quite interesting as to how you can use the software from residential layouts of just 5 to 10 kilowatt to 2 megawatt systems. I'll also be sharing these links with you right now on the meeting chat so that you can look at these designs even from your browser. So I've just shared one design. I'm sharing the other two designs as well. The best part is that whenever you create a design from the Solar Labs software, these designs can be shared with your client or anybody else at the same moment. So I've just shared 3 designs with you. Please do have a look and leave your comments. So coming back, so we have so far got 110 customers all across India. And we have a couple of customers who talk about a software as being very easy to use. It takes, suppose you know the basics of solar design and engineering, even if you've not used any software, it takes just 2 hours of training on the Solar Labs, and you can create from scratch any kind of a solar rooftop and design. Whereas some customers find that we provide them immense value in terms of a single software taking care of all your design problems, from 3D modeling to energy generation and sales proposals. So what we are proposing, like, it's a software which can help you reimagine your operations for remote solar sales. So we have your marketing teams, technical teams, and execution teams who can just use a single software, the Solar Labs. And it's just one platform that can help you create these 6 different outputs. We have a sales proposal output. You can output design reports. You can output 3D models like the ones I've shared with you. You can also, once you create a model like that, you can share it with your customers. You can create PV layouts, CAD layouts from the software, which can be imported into any AutoCAD software, and it is easy to share with your clients. So I'm just opening up one of the layouts that was created using a software. So this is directly implementable into your workflow so that you can create further design requirements after you've created a CAD layout. You can also export a PV-Syst model, which can be directly imported into PV-Syst for further, creating simulations if you want from there, or you can use the Solar Labs simulation, energy simulation reports. So it's a single software that provides you everything in your design and engineering journey for rooftop solar plants and up to 2 megawatts of ground mounted plants as well. So we have a few partners across India where across the Solar Labs platform, we help you in your design journey. So we have partnered with Heaven Design in Gujarat so that you can outsource your designing drawings. If you want to outsource any design drawings, we are able to provide you that as well through Heaven Design. We are working with Octobees to integrate the CRM platform with the Solar Lab software. And not just Octobees, actually, we have created an API structure which can integrate with any of your CRM platforms. We provide demand aggregation services and we are technology provider to EESL. And we've collaborated with Solar Compare so that the leads that are generated across different parts of India can be utilized by our customers. So we do a few consultancy projects as well from our side. So we have some large scale analysis projects. We have side-by-side demand aggregation, and we are able to also execute projects which involve detailed design using drone technology so that nobody from your team has to actually visit a site or put your people in danger for visiting any roofs. Suppose you have to measure a large roof which requires a 500 kilowatt plus installation and the roof is very tall and it's just going to utilizes a lot of manpower and the time. So instead of that, you can outsource that work to us where we can do the drone based site survey and give you accuracy up to 3 to 5 centimeters. We also provide training in the rooftop solar segment, how you can to understand rooftop solar, then a certification to use this software by the Solar Labs. We also provide 2 more courses where if you have sales and marketing people who would like to learn how to sell solar and people who would like to learn how to design solar plants. So we have courses for them as well. So we are now coming to the last couple of slides about our company, and I would like to spend a few minutes here talking about the enterprise software. So if your companies are trying to set up a new solar PV division where you want to take benefit of your existing channel partners or vendors, so you can onboard your entire team and create a smoother workflow by onboarding them into the Solar Labs. It's a single software for design and engineering, right? So that you can leverage your distribution network and reach to a lot more customers with more products. Otherwise, if you're an existing solar developer, we can help you streamline your entire workflow from site survey to proposals very efficiently for your entire team. And it's a scalable enterprise solution. So if you're looking to integrate other solutions as well, we can partner with you to build that solution for your company. So recently, we pulled out a project which was called a large-scale analysis project, where we did the demonstration for a college campus they had 105 buildings, and they wanted to understand what is the solar potential of every building. So instead of climbing on each and every building and trying to measure the size of the roof, we did a drone survey, and we were then able to do the modeling inside the software and create the system capacity estimation. So, we are trying to help government bodies and other private, EPC players to be able to bring a massive change in the Indian market where we are able to determine what is the solar potential of cities. And we hope we are able to provide this service in the Indian market and help you improve your design process. So our team is mainly based out of IIT Mandi and IIT BHU. So we are here to help you build a software for the Indian market, which is going to, again, be a win-win situation for all of us. So always remember, solar power is the last energy source that isn't owned yet by anybody. Nobody taxes the sun yet. So if for any of these things you want to reach out to us, you can. And now let's dive into how the software can be used for various purposes. I'll just quickly take a look if we have any questions so far. So yeah, can you show any ground-mounted megawatt scale layout? If we have time, sir, I'll definitely show you this. Otherwise, I'll be sending you one of those designs in our mails, so that you'll be able to see that design as well for ground-mounted systems. So, we'll now talk about how the Solar Lab software is being, used in the companies. We have got a journey where there are multiple softwares being used by players, right? We have got SketchUp, we have different sales softwares, we have AutoCAD, PVSys being used by different people, and it's a mess of a work. So the design team and technical team is just trying to figure out what is the best design to be made, as well as something what is practical. And what we want to enable is, from your new lead that comes into the picture until regulatory work is over, you don't need to take a lot of hassle. It's just a single software where you can create everything. So we'll be exploring two use cases today. One is how you can use the software to reach out to your incoming leads, where responding to them with a good proposal helps you take the conversation further and give them a good rate contract about what kind of solar plant they want, give them an estimate of what kind of a size is also possible on that roof. So there are 4 steps involved in that process. We gather the site information. In gathering site information, we have the latitude, longitude of the project. We have some photographs and of the roof. And then we also require what is the sanction load, right? What is the electricity consumption of the client? So after you get all of this information, you just hop into our software, create a preliminary design in 3D by using either of the two things. If you have some drone data available, or otherwise if you have the satellite imagery which we provide from different sources, you can create a 3D model, do a quick financial analysis where the top 3 parameters about payback period, internal rate of return, and total return on investment is calculated in an instant. And then you can send a sales proposal, which is quite detailed, and it helps you talk to your customers with more confidence. So that is one approach, that is one use case we'll be going through into the software right now. Whereas there's another approach which we talk about, it's called the detailed design. So detailed design is being done on different softwares. Of course, there are so many softwares in the market where you can do detailed design, but when we talk about doing detailed design on the Solar Labs, you imagine when you're creating a sales proposal, you can manage your multiple designs, you can create multiple designs and try to see what kind of a design is best for the client. You can do accurate 3D modeling in the software, and when you do the custom module layouts, you know what kind of the layout is most suitable to that place. You have all the modules in the software where we have 10,000 different modules. We have got inverters, and the software is built for judging what kind of a tilt and azimuth is best for the software. So you can do accurate shading analysis and the energy simulation estimates. And the last thing that you do into the software is called manual stringing, where you know how many strings and how many panels in each string go into an inverter. So through this, you can then export multiple things and finish your detailed design in the software. So we'll be looking into how we create these designs. And if you have any questions so far, I'll be happy to take any of those questions. Otherwise, I'll just start a design in the next 1 minute. Great. So this is the software, the Solar Labs. Basically, you use your credentials that you get. This is an online software where it's very simple to log in into from any computer. You don't need large systems. You don't need a system with 15, 16 GB RAM or hard drive. It's a very simple software that can run on any laptop. And once you get a new project, so we're talking about a use case where we get a new project and you want to input data for your client. So you click on new project, you insert the project details and the site location. So I'll be now choosing a site location from Noida. Since you're based in Delhi, we will be talking about a project which is based out of Noida here. I'll use the Google Maps to center the project. So there is one RCCA roof, and there's one shed roof that in this project we'll explore. And you get the client details. So maybe somebody from the electrical department has requested this design to you, from you, and you insert the contact number, email, and address. And you click on confirm. So this is how you start off, with creating a new project. And we can also see what we'll be seeing is the 5 different stages of solar plant layouts and modeling. So we have created a new project. It just takes a couple of seconds. Yeah. So here I'll be bringing your attention to 3 things. So now this is called a project summary page, where you can choose the weather file that you want to use for this site. Now this weather file is important for you to be able to do your energy simulation. As a subscription to the software, you get access to a lot of meteornorm weather files, which are preloaded. So according to the project location here, the Faridabad weather file seems to be the closest one. Or if you have your own weather files, you can upload them as well. So if you're interested in using your own software weather files which you have paid for, you can do that. The second thing that I want to show you is that you can insert the client's consumption details. Now this is an industry, so I'll be creating a average monthly consumption of 50,000 units. So if you have an yearly consumption, you can convert it into monthly, then create an average price per unit of say 8 rupees and a tariff escalation rate of say 1.5%. Now, what is 1.5% is that since every year there's some kind of a change happening in the electricity rates or the consumption might rise, so you can give a escalation for that. We have multiple profiles that can be used in any software. What I mean by profiles is that when you're creating a design, you want to be able to select what kind of panels you're choosing, what kind of inverters you're choosing. When you're creating the polygons or different designs, you have the pre-selected, you have got pre-selected modules and inverters in which it makes it easier for you to work with. So we'll be, working with a profile called Delhi here, and I'll be showing you this. So this is very comfortable for anybody in your team to work on. So we'll be creating the shed here, a shed roof. So we'll be naming it Shed 1. So this software is so light and easy to use that you just need your, I'm also on my mobile hotspot. So it's taking a few seconds though. Otherwise, it works very flawlessly even on mobile hotspots. You just need a normal 4G connection. Right. So once we enter into the design software, now this is where we'll be creating the projects, and I'll be bringing your attention to different parts of the software and also to our live support page, where if there's any question that you have, or if you would like to reach out to us, you can directly send us a message, or you can find a lot of answers to your questions in the help site that we have. And you can notice on the left hand side we have multiple tools for say panel placement. We have we have multiple tools for creating the buildings. So we have polygon, cylinder, walkway, trees. So that's the first aspect, right? Whenever you're creating a design, you need to know on what will you place the panels. So we have the tools here to be creating the design. So we'll be choosing the polygon tool. That's the first thing that we need to do, and I'll be creating an RCC, let's not create the RCC roof, we'll create the shed roof today. So this is the shed roof, let's build this here. I'll be choosing the polygon tool. So a shed roof is usually tilted on any of the one sides. So we'll be first focusing on getting the dimensions correctly here. So this looks like, so this image is directly coming from the satellite imagery of Google, and it shows 60 meters. So I can, make it an appropriate 60 meters here. I can also, this is snapping at 90 degrees. So this orange line you see, it automatically snaps at 90 degrees, and I can just change the length then. So it makes it very easier to draw any kind of a layout. So I can again give it a dimension of 19 meters. So I'm pressing the tab button again and again to give it a dimension, and automatic snapping enables me to create a pure rectangle here. So I'll just switch on the arc. So you can see that all the angles are 90 degrees here. And we have a 60 meter by 19 meter rectangle. So this is the first rectangle that we have created. I'll show you. So this is a software that enables designing in 2D, but view in 3D. So we know right now what we have created is a cuboid in shape, and its height is just 2 meters. Now I'll bring your attention to the model properties on the right hand side. Now we want to create a north facing shed roof where the height of the roofs is known to us, or we might guess here based on the base height and tilt height. So we can change both of these properties here. So I'll create a base height of 7 meters and give it a tilt of 8 degrees. Now, once we have done the 7 degrees and 8 degrees base height and tilt, the top height was automatically calculated. So if suppose I'm changing the tilt angle, make it as 5 here, the top height also changes. So basically what I'm trying to show you is that if you have any of the two things out of these three, you can create a shed roof. Then the next thing that you can change is the azimuth. Now, what is the azimuth for the roof? It is the slope of the direction of the slope. So you can see there are 4 directions here from northeast, southeast, and southwest and northwest. So we're choosing 327 degrees because this is the northwest facing roof. And I'll click on placeable and press update. So what we can see here is a roof that is facing in the northwest direction, and we have created our first shed roof. Just a second. I'll request everybody to keep their mics muted, please, so that we can quickly go through this design. If you have any questions, just keep posting them on the meeting chat as well. So yeah, here what we have created is a shed roof facing north, and we can see that there are some turbo vents and skylights. So we again quickly using the polygon tool create those turbo vents. I'm creating a skylight of 1 meter by 2 meter in length. So it's a 1 meter by 2 meter skylight, but I'll need to change the height as well. So I'll make it a height of 10 centimeters, give it a tilt of 8 degrees and the appropriate azimuth, and click on update. So what we see here is one skylight that we have created. So I'll just place the skylight in the appropriate direction. So I can, as you just saw, I have only dragged and dropped this skylight. So basically, if I click on any object, I can place it as per my requirement. So here I'll be placing this skylight, and I can use one of my tools called dimension tool. Suppose you had the accurate measurements available. So if I use the dimension tool, I can give it a distance of say 2.2 meters, and that's what it will be. So for creating any kind of a roof layout, which is also after you've done your site survey, you can use a dimension tool to do it accurately. And I'm now just copy pasting these skylights based on whatever I can see on the roof. Give it a distance of 2.2 meters. And I'll now use the cylinder tool to create these 3 turbo vents as well. So I'll give it a radius of 0.4 centimeter. As you can see on the right hand side, now I'll be changing the height of the cylinder, and I'll click, and you can then work. What you can do is you can see this blue color shaded region around the cylinder. Now, when you're creating such objects which are going to cast shadows, or you need to leave any walking space, so you can directly insert the space that you want to leave without the panel placement. So using the setback tool, you can create what kind of a distance you want the panels to be from this edge. So I've now given it a 1 meter setback, and the same thing can be actually applied to our roof here. So you can see that we have a setback inside of this roof as 1.5 meters. Instead, I'll make it 1 meter and click on update. So you see that now the setback has increased to 1 meter, and of course we don't need an outside setback for this roof, so I click on 0. Now this is a global setback value which is applied to every edge of the roof. So I'll now just paste these obstacles here. And I'm not going to create the rest of the obstacles. It's just going to take a lot of time. So this is how, you know, you can create multiple obstacles on the roof with skylights, turbo vents. You can also, you know, add trees. So suppose there's one tree here, I'll give it the tree a radius of 1 meter and the top part radius of just 4 meters. You can then give it a height requirements on the right hand side. Always, if you have to make any changes to the properties, it's on the right hand side, trunk height, crown height. And this is how our, you know, model has started to look so far. The next step, what we do usually is that this roof can be filled with as many modules as possible. So what we'll do is look at two different steps. One is called the fill face method. As you can see on the right hand side, there's something called a fill face method, and add table mode, and the add subarray mode on this left side. So we'll be using right now the fill face mode. It is one of those smart tools that we have that places maximum number of panels on the roof, and you get a initial idea as to how many panels can be placed and what is the size possible according to the roof. So we see here that 420 panels have been placed with a total size of 132 kilowatt. So based on the profile we chose, the panels that were selected here are Vari Energies 315 watt panels. So based on your requirements, you can either set up favorites here, you can or choose from a list of thousands of panels that we have with their dimensions which are already in the software. So I'll be going ahead and choosing a 350 kilowatt panel from a different company here. Suppose I go ahead with Adani, say, yeah, renews is 350 watt panels. And then I get the option to change the row spacing, the table spacing, and the orientation. Now, these are in portrait mode right now. I can change it into landscape mode. And when I click on update, this entire project will be updated. And now we have a 149 kilowatt system on the roof. So suppose you wanted to, you know, change some of the panels like you can see here. I'll show you to you in 3D. So this is what the system we have created here. Now, you want to add some more panels, you can use the copy paste tool, or you can, you know, select any panel and click on delete. Or if you wanted to, usually when we are designing a shed roof, what is one thing that is important? People should be able to walk on the roof, right? So we'll be placing a few walkways now. So to place the walkways, I'll just select the walkway tool, snap it from one end to the other, and it automatically updates and creates that much gap between them. So I'll create multiple walkways here. So Control C, Control V. Now Control C, Control V, you know, copies and pastes any kind of an object, but I'll show you something interesting now. So we can place multiple walkways here in a different gap. So I'll use a repeat tool and place 5 walkways, right? So doing that enables me to place 5 walkways at a single time and adjust the distance, you know, roof shed. So we have a 143 kilowatt on a roof, and this shows us the initial estimate for this roof. Now here we have to see if these panels are in the shadow area or not. So for that, we have a sun simulation tool. So the sun simulation tool is very simple. Using the date and time on the right hand side, you can you can create an estimate of what the shadow area will be. So I'll create a date of say 22nd December. Usually that's the longest shadow area. And I'll take a time of say 9 a.m. Right. So we see that there is a very long shadow happening on 22nd December at 9 a.m. and this shadow reduces only at not at 10:30 a.m. I guess. Yeah. So at 10:30 a.m. also there are some shadows happening, and we can see at say 4:30 p.m. in the evening also that there are shadows happening here. So instead of once we see that there is a shadow occurring, we can use the panel delete mode, select the panels that were in the shadow area, and be able to remove them. So that's how we can remove the shadows. So you see that now we have cleared off all the shadows at that particular time. We can also otherwise use one of our tools called the solar axis. So now solar axis is a very interesting tool where it calculates for that roof or for that panel what is the percentage of sunlight falling on that roof. So here we see that the solar axis is 85.6. So a solar axis for any panel varies from 0 to 100%. Now, solar axis will depend on the tilt angle and the azimuth angle. So we'll see that this is not a great roof with, we are getting a solar axis of only 85.6. Now we want to take this to 100%. Now this panel is getting a solar axis value of 83.8. Now why is that? Because maybe that panel was having a shadow being caused on it. So we can use the optimize tool, and the optimize tool actually removes the panels which are creating shadow. So you can see that here also some of the panels got removed. Now why did these panels get removed? Because maybe the tree was causing a shadow there. So this is a tool, which helps you quickly estimate which are the panels which are having the most shadow, and you can set a solar axis threshold. So based on the values from the software, you can set a threshold and create an optimized design. So I'll now, like say, hide the solar axis value, restart the sun simulation, and say at 10 a.m. on 22nd December, we have taken care of most of the panels that are shaded. So there's just this one panel remaining. So I'll just click on this panel and delete. Now what we have done is we have created a system of 133 kilowatt, but this is not an optimized system, right? Now we are creating a north-facing roof, which you will be, creating lesser energy outputs. So what we'll do is first test how much energy output is being created from here. So I click on an inverter. I'll choose a SunGrow inverter here. So that's on top for me. That's one of my favorites. So a SunGrow 60 kilowatt inverter. I have chosen two of them, and I click on add. So a software calculates what is the load ratio for this part of the roof: 133 kilowatt DC size, 120 kilowatt AC size. And as soon as we have added the inverter, we can now move on to the next step, which is the calculate generation. So as soon as you have now created the initial layout and added the inverters, we get an annual generation value of 165,000 kilowatt hours and a specific generation of 1,243 units for that year. Now, of course, 1,243 units per year is not a great value, but then how do we improve it? Or what is the right approach to this? So what I'll do is I'll create this shed roof here, go back to my design, and I'll copy this shed roof. I'll create a duplicate copy of this shed roof where I don't need to do a design again. It's just going to take a couple of minutes, and until then I'll answer some of the questions. So how software will calculate shadow area? Yeah, so the shadow, like Siddharth has already answered this. He's the CEO of the company. So we can give you the different mount heights when you're creating a design which is for a normal RCC roof. So you can tackle the shadow which is being caused on the roof. So now what we have done is, in the project summary, you can see that we have created two designs. One is the first design that was shed one, and then we have created a design called shed one copy. So in first shed, what we did was we had a system. We created a like energy output from January to December. What we can see here, the panel performance is very good from March to June, and we get an energy output of 165,000. And what we can see is that the global incidence on PV plane is less than 4, is reduced by 4.6%. So actually, because of the poor tilt and azimuth, our panels will not perform that great. So what we can do is instead go back to the alternate design and create a better or an optimized layout. Now, of course, we know that when we are designing a north-facing roof, we can create a layout which is reverse tilt kind of a structure. So I'll select the same panels again. I'll take the 350 kilowatt panels here by, just a second, please. Okay. I'll go to I'll choose the same 350 kilowatt panels from Renewsys. I'll choose a fixed mount template. I can change the tilt angle now. So the tilt angle is with respect to ground. I can change the tilt angle to 150 degrees, 15 degrees. I'll change the azimuth to southwest, which is 147 degrees. And I'll just remove this here. Yeah. I'll click on the row spacing method as manual. So our software gives you two options. So right now what you can see is a row spacing, which is automatically calculated, but instead I'll choose an auto row spacing, click on 1.5 meters as manual row spacing, make it a landscape module and change the height. So once I click on update, our software creates a layout right now, which is, as you can see in 3D, facing almost in the south direction. Okay, so this software is, can do it automatically, and then you can use the sun simulation tool to test if your design is actually appropriate for the longest day of the shadow, or you can create different parts of the day as well. So at 10 a.m. also there is no shadow happening here, and the evening at 3:30 we can check if there's any shadow happening. So there's no shadow. You can check for different parts of the year. So 1.5 meters seems to be a safe design layout. And what we can do next is check the solar axis. Now again, now the solar axis depends on tilt and azimuth, and now what we can see is compared to an earlier solar axis value of 85, we have a solar axis value of 95.8 on this roof. And this average solar axis is 95.5. So it's a well-designed system, but what we are sacrificing here is the total size of the system. Whereas earlier we had a 133 kilowatt, we have a 63 kilowatt system. So we'll just add one inverter of 60 kilowatt and click on add. So this design is right now completed with a 63 kilowatt size, and we'll calculate the generation. So if you might remember, the previous specific generation was just 1245, but this time we have a better specific generation of 1424 units. So we'll click on save. So this design is done. So what this software now enables you is that you can provide your customer multiple design options, right? So this is a reverse tilt shed. So I'll give it a name, reverse tilt shed, reverse tilt, and click on confirm. So here what we see is that in this design, the global incidence on PV plane is higher. So this is 6.78%, whereas in the previous case, this was falling by 4.7%. And our energy output for every month is also changed. And now what we are going to do is, so our software also provides a bill of materials. We'll see what is the financial analysis. Basically, when you're creating these two different kinds of layouts, the pricing for both will be different. Suppose now this is a reverse tilt roof. So I'll give it, along with the structure, a rate of say 40,000 rupees per unit. I'll give it no subsidy. I have an option for giving it an accelerated depreciation. So I'll give it 40% percentage, 40% of accelerated depreciation benefit over 3 years and a 30% tax slab. So as soon as I click on confirm, the software calculates what is the ROI, IRR, and payback, right? So we have a payback of exactly 3 years with an IRR of 30.8%. Now, what about our other shed? So our other shed, we should see what kind of a payback do we get here. So when I click on pricing and I put a price of 40,000 rupees and the same accelerated depreciation values, 30% there, 3 years, I'm sorry, 40%, and tax slab of 30. Click on confirm. So here we get a payback period of 3 years, 5 months. So what is the loss here? So we see that this is an ROI of 1 crore 19 lakh rupees over the lifetime period of 25 years, 1 crore 19 lakh rupees, but the payback is happening in 3 years, 5 months. Whereas compared to the other shed, which is a reverse tilt here, we are getting an ROI of just 68 lakh rupees, but a quicker payback period. So you have an option to create 2 different reports or sales proposals with the ability to choose different pages. So now we are at the last part of the software where we are creating a sales proposal for the design, and you can choose the different time you want to be, create the shading report as well, and then click on confirm. Right. So by the time this shading report is being completed, I mean, this sales proposal is being prepared, I'll also bring your attention to one of our designs that we created on our residential roofs. So this is kind of unique, where in a residential roof, you cannot use that kind of a tool, which is for, creating multiple tables. So we created a sample layout from earlier. So this is a residential roof colony where I've, just created this place, and I'll be placing some of the panels on this roof. So this roof right now, Yeah, so this particular roof, you can see, will see shadow falling from the north side of the panels as well, the north side of the roof. So you can switch on the sun simulation. You see it's quite complicated by, being multiple types of buildings nearby with trees and all. So we'll try to see how using a software you can create an accurate rooftop. So what we see is an azimuth value of 171 degrees, which is appropriate here. So I'll be going to the add table mode. Here we have already selected the panel make of Jackson with 350 watt peak and tilt value of 22 degrees. We'll select 171 watt peak and create a table size of 2 by 1 portrait and height of 2.5 meters. So I can quickly place these panels. For this roof, I can automatically place the panels on the backhand side as well. And click on complete. So I hope this was ignored. Okay. So now what you can see is we have created a roof layout here, which shows us maybe we'll have to do a solar axis analysis. And we can then understand if these panels are placed appropriately or not. So for creating a residential, we have a different tool. So you see that this 2.5 meters is not a good enough height because of the trees that are present and because of the gaps here. So we can, click on the sub array, increase the height to say 4 meters, and then try to see what is the impact of how is the solar axis being here in this new design. So it looks like this roof needs to be optimized further. There will be always shadow here. So this is not design here, but you see that this roof is a good one without any shadows, and that's how you can create residential designs. So coming back to our previous project, so this is one of the sales proposal that is created using a software. So this is the first page of the report. When you're creating this report using your company, you can put up your logo here. And this is the model for this is the link for the 3D model view. So this is something that you can share with your customer. I'll be sharing with you in chat right now. So an IRR of 30% is available here because of the discount rate that we are choosing, which takes into account the present value of net present value of the money. So in this tool, what I've just shared with you, you can see that there's a sun simulation as well, and you can see what is the return on investment and payback period. So the client is interacting with your design and giving you feedback or his understanding about his rooftop. So the end goal is that using a sales proposal, you should be able to market your company, talk about your company as to how your company is providing data to your customers, where and all your company exists, and then provide them the system metrics. So we have a slide for system metrics, which shows the annual production, performance ratio, and specific generation with the module DC nameplate. You have the total savings slide here. So this is one of the important slides where you can show what is the financial savings happening. When you see using this graph, you can talk to them about the first year, there's an investment that goes into the system, but over 25 years, you're having a lot of savings. This is the slide which talks about the components that are being used in the system. This is the monthly production value. So now what we'll be going into is, this is a design report, a sales proposal, but as well as having enough data about the annual generation values in this proposal. So we have a monthly table from January to December, how much irradiation falls at that location according to the weather file, and what is the final output. We have field segments here. You can see we created a 15-degree tilt field segment with 1.5 meter row spacing. This is one of those slides which talks about the shadow analysis, as you can see, for different times of the year from 9 a.m. to 5 p.m. and on December 22nd, 9 a.m. to 5 p.m. So this slide tells that we have a 99.4% shadow-free installation throughout the year. This is the losses table, which we saw for the design summary, which is also present in our sales proposal. And this is one interesting slide which we have. So using this slide, you can talk to the customer about what is the bill with solar and without solar. So the white color columns is the bill that the customer would be paying if he installs the solar panels. So you can see that there is a net benefit which the customer reaps in 25 years. So using this sales proposal, when you're talking to your customers, you can connect with them on multiple aspects. You can clear all your customers' doubts and not just create a sales proposal, but you can do detailed design and engineering like we were talking about. So this is one of the sales proposals that we created here. So I can also create a CAD layout which can be exported from here. I'll be creating both the CAD layouts since we have some 2 minutes left. We're creating both the CAD layouts and then open up my Autodesk viewer and upload these CAD files. So I'll show to you that whatever design you're creating in the Solar Lab software can actually be implemented on site, and you can then create detailed drawings through the software, through your other softwares. Rahul, that's a great question that you have. Which radiation is being used for generation calculation? Is it GHI or GII? I will have to get back to you on that. This is something technical which I also don't know. I'll talk to my team and let you know about it. So okay, somebody is asking me for a suggestion of a software for ground-mounted systems with contours. So I think right now a software that is available in the market is AutoCAD, which can handle such designs, AutoCAD 3D, so that you can create ground-mounted systems with contours. Now, this is one of our AutoCAD files which have been generated using the software. As you can see, we created a layout of 19 meters by 19 meters by, I think so this was 60 meters, right? So we can see that when we take the measurements, yeah, so it's a 60 meter by 19 meter roof, which you can then import in your AutoCAD software and make the dimensions. So our panels are 1.985 meters and 0.955 meters in length and width. So basically, this is a layout which is actually implementable on your site. So basically, I've given you a brief view about our software. And if you have any other questions, please continue to ask them via the chat. Now, there's just in the next 2-3 minutes, I'll be showing you one of our designs that we did through the drone survey and showcase you how we can bring that workflow where you can be sitting in your office, say in Pune, and even if you have a client somewhere in Nagpur, you don't even need to do a site visit, and we can get somebody to do the site visit for you and provide you all the 3D data. So if you have any questions regarding so far about the solar panel design, the solar design, and the sales reports, I'm ready to take those questions. You can use the meeting chat to put in your answers here. Okay, so let's move on to our design that we created for the using a drone survey. So we have hosted the drone data on one of our partners' websites. So while that loads, I'll also load the design that was created using our software. So this project was done for IIT Mandi actually. They wanted a proposal. They wanted to understand what kind of panel layout can be created for their roofs. So we created multiple designs after doing the 3D and layout analysis, 3D analysis basically with the measurements. So this is one of the designs that I'm loading up for you guys. It's just a little bit of heavy data, so just pardon me. Give me a moment, please. So this entire screen you see right now, where we have got multiple buildings on the roof. I mean, we've got multiple buildings here. This is the IIT Mandi campus. It's in between. It's in a valley with multiple, with hills on both the sides. And we did a drone survey here, where this data was, created through 3D modeling of that roof. I mean, 3D modeling was done using a software after the data collection. So this is where we can do the same thing for you. So once this 3D modeling is done, you can take up measurements. Here, I can say pick up the measurements for the roof. So this is say 42.87 meter roof. So this is like basically 13-meter roof, and we have our design here. So it's the same design. As you can see, it's the same 3D model, which we have reconstructed here compared to this one. Oh, wait a second, please. It's the same 3D model, like you can see. And we can now also, we can do the measurements here as to what was the design, the dimension here. So yeah, this is like 12.99 meters. So it's almost like 13 meters that has been created, 13.07. So that's how the drone data that was collected and can be utilized into solar design. So this was quite a complicated shed roof. So you can see that people cannot climb on this roof to do the measurements. So one of the ways is that either you have the accurate CAD layouts, but CAD layouts cannot tell you the angles. So there was really no other way to create a solar module layout without having the accurate dimensions for this roof, which we were able to do it for this site. So we were able to calculate accurately what is the solar axis, what is the generation that is expected here, and then create a panel layout. So this is one of the designs which we hope we'll continue to work with other EPCs for different industrial areas. And in our upcoming webinars, we'll have one webinar where we'll showcase from starting to end as to how you can integrate drone imagery and 3D models into the software and create your designs without site surveys. So this is just a brief overview. And thanks for joining in, people. We'll keep this meeting link open for the next 5 more minutes. And if you have any questions, I'll be happy to answer. And for whoever has joined the meeting and would like a recording, I'll be sharing the recording link with you in an hour or so. And also the outputs that are created using the software, if you would like them, please let me know and we can continue the conversation. You can see on our website the different kinds of documents, the technical notes we have, how we do the energy simulations. You will also find one of the documents which shows that the shading analysis is TUV certified. So our software is quite detailed, and it can take you from site surveys, like from pre-sales to detailed design in an instant. Okay, so basically our software is, the pricing for the software is on the website. I'll just bring it up. Yeah, so we have, depending on our customers, what kind of usage they have, we have 3 major plans. So if there are only small and medium businesses looking to do only residential projects, we have a light tier plan. Apart from that, if you are looking to do commercial projects up to 2 megawatts, we have a basic plan which is rupees 60,000 per year. And using a software, you can create all those kinds of outputs. But if you're looking for an enterprise level solution where you want to export SketchUp files, have some API integration and project sharing facilities, we provide this enterprise tier as well, where we also do we can build a lot of customizations for your team. So there's a person asking, what is the cost of the drone survey? It's an interesting question. So here, the cost of the drone survey for me, for this particular site, was very different compared to what happens. So suppose if you're doing a drone survey in one of the major cities where our drone service providers are available, so where our partners are available, for 1 day's of work. So basically, if you're doing a drone survey for one site or multiple sites at the same location, but for 1 day of work, which is a minimum charge, we can do this drone survey and your data provision in rupees 20,000. And if you're able to collect your own drones data, then the processing and design services can be given to you at rupees 10,000 per site, up to 1 megawatt. So depends, basically, it depends on the costs involved for traveling to that location and otherwise. So it starts at around 10,000 rupees and goes depending on the location that we'll be going to. So thank you guys for joining me in this webinar. If you're really interested to see how this software can work for your organization, please write to me. We can give you a trial account, or also, and also if you come on board the Solar Labs, we will give you a lot of training to help use the software as well, but also training regarding how you can do better sales and design. So once you're part of the Solar Labs organization and use our software, it's a lifetime support that we offer, and we work very closely with all our partners. So thanks for joining in, and do write to us for any queries that you might have. Thank you.